All right, so this is a very quick one, and in this one we are going to deal with object-oriented programming, or basically classes, and everything we've dealt with so far is going to come together, especially with what we recently covered, which has to do with the functions. So we are seeing that object-oriented programming, which is OOP, is a programming paradigm centered around the concept of objects. In this paradigm, the structure of the code revolves around modeling real-world entities, where each entity is represented as an object with its own attribute, which is data, and the behavior, which is methods. Now, OOP emphasizes the organization of code into reusable and modular components, making it easier to understand, maintain, and scale. So there are lots to read over here, but then let me just go back to this so that we can move very quickly. I have some few illustrations I'm going to work with over here. All right. Now, in order to also move very quickly, in the same handout, on page 77, where we have the past questions, okay. When you come to this particular, I think there's a typo over here. We have it as question 4, okay. There's a major question on object-oriented programming, and practice this, okay. It's going to help you. Now, the question reads: you have been tasked to develop the C++ backend code for the Lands Commission to aid in the digitalization of all lands in Ghana. The application will enable the commission easily calculate the parameter, first the area, the parameter, and diagonal length of plots of lands. Follow the instructions below to develop the code. The first one is to create a rectangle class. The second instruction over is to write a constructor method in the rectangle class and assign the following attributes: length and width. Now, create an area method that calculates the area of a plot of land. Create a perimeter method that calculates the perimeter of a plot of land. Now, create the diagonal length method that calculates the diagonal length of a plot of land. And you have some useful hints over here. So, basically, every prompt I give in the exams, there's going to be some hints in terms of how to, the logic behind the calculations will be given to you. It is yours to just pick it up and then write it in code for me, and it's very simple. Now let me come back here. We are dealing with object-oriented programming, okay. We are saying that it's a programming paradigm why every piece of logic in terms of our code is centered around the object. So we need to understand some few things over here. Now, in order to understand these objects, let me zoom in a little bit. So this is a whiteboard I'm going to use. So in order to understand these objects, because we are saying object oriented, okay, we need to understand something we call classes, okay, or a class. And typical of the exams, it is asking us to create a rectangle class. So definitely we know what to do, or we are going to see how we go about it. Let me just clear my thing over here, and yes, we are good to go. So let me come back. Now we are saying that, okay, for object-oriented programming, the programming logic is centered around the object, okay, every programming logic, and the word is OOP, or the acronym is OOP, object-oriented. So the key word we have is the word orient, okay. Now when you check through the dictionary, let me just go onto the internet and look at the word orient. The word orient, okay, let me look for the word oriented, okay. So the word orient has a number of synonyms, okay. So one of it is align, position, okay, or tailor, adapt something to a specific circumstance, something like that, okay. So grammatically, to say object oriented, we can say object position. So everything, all the programming logic is centered around the object. So the question is, what is this object? Now this object is going to be created from the classes, and in order to understand this very well, let's go to the bakery, because that's where I think the scenario I use in most of my illustrations. So let me just draw this. Now when we go to the bakery, okay, they have these let me just try and get this in isometric. Very nice. They have these pans, okay, molded in aluminium. They use in baking bread. So let's call this the baking pan. Now this baking pan is more or less a template or a blueprint for which bread object or bread will be baked. So out of this baking pan, we are going to have maybe this loaf of bread. Okay, so maybe this is butter bread, and let me just name this the bread. So practically, of course, the bread is the object, okay, and the baking pan is the mold or the class. So this bread is out of this class, okay, or this baking pan. So the relationship between the objects and the class is like that. The class is a template for creating objects, and the object is a creation out of the class. That's basically that. So when you go through the handouts and then you come to this, we are going to see that, okay, there are some key terminologies you need to understand. And the first one is the object. An object is an instance of a class, and it represents a real world entity. Okay, now they condense data, attributes, and behavior methods, which we are going to come back to. Now the class serves as the blueprint for creating objects. So over here you could clearly see that if the baking pan is, let's say, rectangular in shape, the bread object that's going to come out is going to take up that shape. Okay, so when we are using object-oriented programming, it gives us a structure for which code should be put into. Now this structure is probably going to make more sense if you look at the bigger picture. So the bigger picture is, let's say, your student system. Okay, so let's say the ATU student portal, and with the student portal, everything we have over there in terms of the programming logic is object oriented in nature, in the sense that, well, there's going to be a template, and that template is going to shape how every student's records is going to be in the system. So this is what it practically means. So over there we are going to have, and for instance, the data that you provide, okay, when you are doing, I mean, the first time you ever got into contact with ATU in that practical sense was when you bought the forms and then you fill the form. Okay, so you fill the form, you submitted, you gain admission, but then in filling of the form you provided some data of yourself. So for instance, you provided your name, your age, your gender, your grades, okay, your phone number, and other things. All right, so this is going to be the data, and then, or we are also going to call these the attributes. Okay, so this is going to be the attributes, and then out of this, okay, some actions, which we are also going to call some methods, or we can loosely say some functions. Okay, some methods are going to be created out of this. Now one of the typical method is for instance, maybe out of the data that has been provided, we can do certain things. Okay, so you can do course registration, and in the course registration there are a few things that you do. You can add courses, you can drop courses, depending on how the system is. I don't know how your system is, okay, but for instance, from where I sit as a lecturer, some of the methods or some of the actions I can take is I can grade students, and if for instance there's a problem with the grades, then the right or appropriate channels are used. I can request for a change. Maybe a student got an A, and mistakenly I give the student an A plus. I can request for a change, and trust me, it's a very long process. Write a letter to the dean, it goes to the VC, pro VC's office, and you provide the evidence that this was a typo, it was a mistake, and then that change will be done at the appropriate time. So these are things that we can look at as the bigger picture. But let's shift our focus on what we have over here with this particular example. The question says we should create a class rectangle. So that's going to be the template, and all lands, we are assuming they are all going to be rectangularly shaped. Okay, So in order to do this, it's very simple. We once again have to come outside of the main function. Okay. And then we say class. So we use the keyword class and then rectangle this way. And then we have it this way. So once you have this, you have actually answered the first question, which is the question A. And at the end of the day, the total max is 20. So maybe you get a 2 over here, or maybe a 5, depending on how things have been structured. But then this is just to show you that it is very simple. Okay. Now the second point is we need to create a constructor method. So now the keyword we have over here is a method. Now a method and a function are the same practically. Okay. But then why then do we call one a method and one a function? So this is the example I cited in class with the other groups. And let's assume this is myself. Let me just use some illustrations over here. So I'm going to have this. This is me, okay? A very funny man. So this is K Brony. And let me use this red one over here. This is, let's say, your course rep, okay? And your course rep, this is a course rep, and this is me. And your course rep is maybe my nephew, okay? My nephew, by virtue of the fact that, no, okay, so your course rep, this is the example I use. So your course rep is my uncle, okay? By virtue of the fact that he is my mother's brother, but maybe a very younger brother, okay? I'm older than my uncle, technically. Now, when we come to the compounds or the walls of Accra Technical University, he's not going to see me and say, hey, my niece, come here. No, that's not going to be a proper way of addressing me. He's going to call me Ose or maybe the lecturer. So the relationship that exists between the two of us is going to be a student-lecturer relationship. Now, when we go home and maybe there's a family meeting, my uncles, the elderly people are meeting, he can go and sit in and make contributions, no matter how young or how old he is, okay? But I cannot go and sit in. And when we go home, the relationship that exists between the two of us is going to be an uncle-nephew relationship. Now, the point is, whether it is uncle or whether it is school or whether it is home, I don't change as a human being, okay? My uncle does not also change as a human being. However, whether I am a lecturer or a niece, okay, a nephew, or whether he is a student or an uncle, the bottom line is I assume that name or that title of a lecturer only if I am in the confines of the Accra Technical University, okay? And that's exactly what happens with functions. Now, functions and methods are the same. However, it is a function when it is outside of a class, and if it is inside of a class, it is a method. So the point you are trying to make is we can have a function just as the functions we wrote earlier on, okay? So the greet function. So when I say let's say void greet void greet function this way, and whatever logic I write, okay? So let's say I'll do a cout and I'll say hello Ken. This is what we saw earlier on. When I do it this way, this is outside of the class, okay? It is outside of the class. So this is a function. But then when I write this and come and do void, let's say, let me call this salute function. I just want to use different names so that they are very clear. And inside of this, the logic is also saying cout and hello Ken. So let me just scroll down a little bit over here. Now, as far as this logic and this logic are concerned, the only difference clearly are just the function names, okay, or the names I'm using over here. But then the logic is the same and the structure is the same. But because this is outside of the class, we are going to call this a function. And because this is inside of this class, we are going to call this, how do you call it? A method. Okay, so this is going to be a method. Now, something interesting is going to happen. Now, if I come outside of this and come and call this the greet function, okay? If I call the greet function and I run this, we don't seem to have a problem. I have hello Ken over here. So let me just write something that will make it a little bit distinctive. Okay, so this one is going to be hello Kenneth, and then this one is going to be hello Ken. Okay, just so we see the difference. So when I run this one is going to be hello Kenneth because this is a greet function. Okay, now the salute function, which is practically the same, however, because it is inside of a class, we are calling it a method. If I try bringing the salute function over here, the salute, okay, the salute function, I'm even struggling to type this because it is not showing up. When I run it this way, we have a problem, and it says that the salute function was not declared in this scope, and that's simply because of what we are saying over here, that this is object oriented, so all the programming logic should be centered around the object. So now the big question is, what is the object that we are talking about? And we are saying that the object is going to be a creation out of the class. So this is how we create an object. Now, in order to create an object, it's very simple. Now, one of the things I also need to mention is classes are user-defined data types. Okay, so remember, before we create any variable, we need to present or we need to provide a data type. We know the int, the float, the char, the double, and all those bool and other data types that we know. Now, what about if there's something we want to do, but there's no specific data type we can think of? That means, okay, then we can create our own class, and after we create the class, that class becomes our user-defined, our own data type. So what is happening over here is this class is our data type. Okay, so for instance, I can say that, okay, rectangle, and this rectangle, I'm going to say plot 1, and I'll instantiate this way. So rectangle plot 1. So this rectangle becomes the data type for this plot 1 quote unquote variable. But then, like I'm saying quote unquote because this is actually a creation out of this rectangle. So this then becomes the object. So now look at this. I have this over here. Now when I run this, there's no problem, okay, because I've done the proper thing. I've created an object out of this rectangle object. Rectangle class. Now, because this is object-oriented programming, if I want to call this function, because all the programming logic is revolving around the object, because it is object-oriented, I now have to do plot 1, which is the object. Then I'll do dot. When I do dot, the dot is almost as if I want to go into it. Okay, so we call this a dot operator. Then I have this salute function over here. Then I'll invoke it this way. So now when I run this, we have an issue over here. So let me just scroll up a little bit. It says request for member salute function, which is okay, so it says request for member salute function in plot 1, which is of non-class type. Okay, so we are going to resolve some of these things later, but then let me just quickly do this and see if this one will work. So let me just say public over here so that it becomes public. So now let me run this and see if this one will work. It is still not working over here. Let me see. Okay, so this one is working now. Let me get rid of this public and see if it will work. Okay, it is not working. All right, so what is happening here is, and let me just explain quickly. So yes, we have created the object, which is plot 1, okay, from the rectangle class, and then because it is object oriented, we are saying that plot 1 dot, all the programming logic is revolve around the objects. I'm saying salute function. I want to invoke this salute function, and inside of this salute function, the logic is hello Ken. But then it is telling me that this salute function is private within the context. So if it is private, then I need to make it public so that everybody can see. So now when I make it public by just bringing up public and the colon over here, now when I run this, everything is working over here. So we have hello Ken, which is the content of the salute function. Now if I come here and just call the salute function this way and run this, it is not going to work. And it's not going to work because we have written a class and we have created an object. And if we want to invoke a function, because this is object oriented, it needs to revolve around the object. It's as simple as that. So that's the emphasis I was trying to make over here, that every piece of logic is going to be oriented, is going to be positioned around the object. So over here, you could clearly see that, okay, we are going to say that we are going to have instances of the class and we are going to represent real world entities. Now, the objects are going to condense, or they are going to put together data attributes and the behavior, which is also the methods. So we have some few examples over here. So this video is going to be in parts, okay, because it is quite long. So let's just end the part 1 over here. The part 2, we are going to answer the questions as we have over here and as we move on. But clearly we know what these methods are. They are basically functions, but then they are within the confines of a class. That's why we call it a method. And it is only going to be accessible by objects of that class. So plot 1 was an object of rectangle, and that's the reason why we can have access to the method inside of the rectangle class. All right, so this is going to be the end of part 1, and then part 2 will follow up with some interesting things.